Engineers Academy. Do hit the subscribe button if you are here for the first time. Now we are going to solve this problem, which is related to the panic escape. And the problem says that figure 221 shows a general situation in which a stream of people attempt to escape through an exit door that turns out to be locked. The people move toward the door at a speed of 3.50 meter per second, or each of depth 0.25 meter, and are separated by a distance 1.75 meter. The arrangement in figure 221 occurs at time t equals to 0. So we are required to find the average rate. At what average rate does the layer of people at the door increase? So, and in the second part it is said that what time does the layer depth reach 5.0 meter. So in the first part, first of all, we are given the velocity of the speed of the man, the speed of the bodies, or the speed of the human that are approaching towards the door. So we are given Vs. So Vs is 3.50 meter per second. And then the depth of each human being, the depth of each body is 0.25 meter. And the distance between each body is represented by L, and that is 1.75 meter. So this is the distance L and the depth of each body. So all these information is given, and in the first part we are required to find the rate. So at part A we want to find the rate at which the depth increases in front of the door, or we can say that the depth of the bodies that is accumulated at the door. So the rate will be equal to the depth of bodies divided by delta t. So the rate is like just like the velocity. So the rate is equal to the depth of the bodies accumulated per unit time. So d divided by delta t. And we are given Vs, the velocity of each human being. So we know that Vs, the speed, will be equal to the distance traveled. So the distance traveled by each body towards the door at a given time is L divided by delta t. Let's say if we are talking about this human being only, so he travels a distance L towards the door, and we are given Vs and L is given. So we will be able to find the time taken by this man to reach the door. So we will be able to find delta t. So delta t is equal to L divided by Vs, and now L is 1.75 and Vs is 3.50. So 1.75 divided by 3.5 is 0.5. So delta t is equal to 0.5 second. L is in meters and Vs is in meter per second. So we will get the units of second. So this body will take 0.50 second to reach this door. Using this formula we will be able to find the rate. So the rate will be equal to the depth. So depth of single body is 0.25 meters divided by 0.5 second. So 0.25 divided by 0.5 gives us 0.5. So 0.5 meter per second. So each second the depth of the bodies is accumulating at a rate of 0.5 meter per second. So each second the depth is increased by 0.5 meters. So this is that rate which was required in part A. Now in part B it is said that at what time does the layer depth reach 5 meters. So now the depth is given, the total depth is given. So let's say that the total depth is capital D, and that is 5.0 meters. So as we have discussed that each second a depth of 0.5 meter is accumulated. So now we know the rate. So the rate is now equal to D divided by delta t, and we want to find the time taken for delta d, the time taken by accumulating 5 meter of depth. Delta t is d divided by the rate. Now d is 5.0 meter divided by the rate is 0.5 meter per second. So delta t will be equal to 10 seconds. So it will take only 10 seconds for the accumulation of the depth of human bodies of 5 meters. So this answer reveals that how quickly such a situation becomes dangerous when there is some emergency. So this is the solution of this particular problem. I hope it will help you in your learning. Do subscribe Engineers Academy for the solution of such more problems related to fundamental of physics.